All right, welcome to this explainer for KS2303 Signals and Systems. Today, we're diving into your essential toolkit for manipulating signals. Think of these as the fundamental verbs of signal processing, right? The actions you're going to use all the time, from audio mixing to telecommunications. And trust me, nailing these down is absolutely key. So here's what we've got lined up for the next few minutes. We'll start with the main idea of how we combine signals. Then, we'll break down the three big operations you'll be using constantly: addition, multiplication, and scaling. We're also going to tackle a really common pitfall that trips up a lot of students. And finally, we'll wrap it all up with a quick summary to make sure it all sticks. Okay, let's get right into it. The big question, right? How do we actually take simple signals and build something more complex, something more interesting? Well, it all starts with a basic toolkit. You know, the easiest way to wrap your head around this is to just think about signals like they're numbers. I mean, you already know you can add numbers, multiply them, and get a new result. Well, it turns out we can do the exact same things with signals, using them as building blocks to create way more complex and useful waveforms. Okay, let's kick things off with our first tool, and it's probably the one that feels the most natural: signal addition. Now, the key idea here, and you're going to hear this a lot, is that it happens pointwise. So what on earth does that mean? It just means that for any single moment in time, let's call it t, you take the value of the first signal and you literally just add it to the value of the second signal at that exact same moment. You just do that for every single point in time and boom, you've got your new signal. Okay, let's make this super clear with a classic example from your course book. We're going to take a constant signal, x1 of t, which is just a flat horizontal line at a value of 2. We call that a DC signal. And we're going to add it to a good old sine wave, x2 of t, which, as you know, just swings between +1 and -1. So what do you think happens when we add them together? Well, the result is that the entire sine wave gets lifted straight up by 2. So instead of oscillating around 0, it's now oscillating around a new center line of 2. It goes up to 3 and down to 1. Simple as that. All right, next up in our toolkit, signal multiplication. And this one's a real game changer. It's not just for combining signals. It's for using one signal to actually control another. It's fantastic when you want to gate a signal, which just means turning it on or off, or for modulation, which is pretty much the foundation of all radio communication. And yep, you guessed it, just like addition, this is another pointwise operation. At every single instant in time t, you take the amplitude of the first signal and you multiply it by the amplitude of the second. Okay, here's a classic example, one you'll see over and over again. We've got a sinusoid that just goes on forever from -infinity to +infinity. And then we've got this really special signal called the unit step, u of t. It's super simple but so powerful. It's 0 for all negative time, and then at time equals 0, it instantly jumps up to 1 and stays there forever. And this is where the magic happens. It perfectly shows the power of multiplication. For all negative time, the sinusoid gets multiplied by 0, so the output is just 0. But the second we hit t equals 0, the step function flips to 1. Now the sinusoid is being multiplied by 1, which means it suddenly turns on. That step function basically acts like a perfect light switch. Okay, our third and final core operation is amplitude scaling. This one's all about changing a signal's strength, its vertical size, or even flipping it upside down, all without moving it left or right on the time axis. Honestly, this might be the simplest one to visualize. We're just taking our entire signal, x of t, and multiplying every single point on it by some constant number. We'll just call it a. And with this one simple multiplication, we can make a signal louder, quieter, or completely invert it. And this slide just lays it all out so perfectly. Look, if we multiply by a number bigger than 1, like 3, we amplify the signal, we make it taller. If we use a number between 0 and 1, like 0.5, we attenuate it, we make it shorter. And if we multiply by a negative number, like -1, we completely invert the signal, flipping it over the time axis. 3 simple constants, 3 really different and useful results. Okay, listen up, because this next part is super important. This is a critical pitfall where a lot of students get tripped up, so let's make sure we get this crystal clear. So, take a good look at this. On the left, we've got 2x of t. See how that 2 is multiplying the whole function's output? That's key. It's multiplying the whole function's output. It's scaling the amplitude, making the signal taller. Now look at the right, x of t minus 2. The change is inside the parenthesis, messing with the time variable itself. This doesn't make the signal taller, it shifts the whole thing to the right. These are two completely different operations. And there's a reason your course book really hammers this point home. If you mix these two up, you're going to run into major problems down the line when you start analyzing systems. So just always ask yourself, is the change happening inside or outside the parentheses? That one question will tell you exactly what kind of operation you're dealing with. All right, let's do a quick recap of the 3 powerful tools we've added to our signal processing toolkit today. So in a nutshell, addition is all about combining signals. Multiplication, that's for shaping or gating one signal with another. And amplitude scaling, that just changes the vertical size or flips it upside down. If you can master these 3, you've mastered the essential building blocks of signal manipulation. And there you have it, our tour of basic signal operations. As we finish up, I want you to really think about this. Just by using these 3 simple tools, addition, multiplication, and scaling, in different ways, what kinds of incredibly complex signals could you build now? From the sound of a musical chord to a radio broadcast, the most complicated waveforms out there are often just built from these simple beginnings. And that's where the real power of this toolkit is.